Hello, I'm your teacher of this lot. I'm Tu Mayin from SMJK Notre Dame Convent, Malacca. Today I'm going to share with you what is the meaning of specific heat capacity. So let us start right now. Right, learning standard. Pupils are able to explain heat capacity, define specific capacity, communicate to explain the application of specific capacity in daily life, material engineering, and natural phenomena. And also know how to conduct experiment to determine the specific capacity of water and aluminium. Right? Okay, what is the meaning of heat capacity? Heat capacity is represented by using the capital letter C. Well, heat capacity of an object is the quantity of heat needed to raise the temperature of object by 1 degree Celsius. Therefore, we are having a formula here whereby capital letter Q represent quantity of heat supply. Delta theta is the change in temperature. Or we use a final temperature to minus the initial temperature. Unit for heat capacity is joule per degree Celsius. So from now onward, you must know what is this formula means. Okay. Next, let us have a look. When 100 joule of heat is supplied to an object X and Y, we are having two objects. So object X experiences a rise in temperature of 1 degree Celsius, while object Y having increase in temperature of 2 degrees Celsius. Question asking, what are the respective heat capacity of object X and Y? So we calculate separately. First of all, we have a look at the heat capacity for object X, or we can represent by using C with the subscript X. Alright? So, given 100 joule divided by 1 degree Celsius, okay, 1 degree Celsius because stated in the question, object X experiences a rise in temperature of 1 degree Celsius. Okay? So, after we substitute here, we can get our answer is 100 joule per degree Celsius. On the other hand, heat capacity for object Y, or we replace or use the symbol Cy, okay, given 100 joule divided by 2 degrees Celsius because stated in the question. So the answer is 50 joule per degree Celsius. So we can say that object S has a high heat capacity than object Y. You can see from here. 100 joule per degree Celsius is greater than 50 joule per degree Celsius. We can say that here conclusion is increase in temperature of object X is less than object Y. Well, the next important word will be the word specific. Okay, specific we refer to 1 kilogram. 1 kilogram of mass. So therefore, specific heat capacity, lowercase of c, of substance is the quantity of heat needed to raise the temperature of 1 kilogram mass of the substance by 1 degree Celsius. So we emphasize on the word 1 kilogram of mass. Therefore, we're having this formula. So we are having two formulas already. So here we should know that Q represents quantity of heat supply. The unit is joule. Mass M, unit is kilogram. Delta theta is the change of temperature in degrees Celsius or Kelvin. Therefore, the unit for C is joule per kilogram per degree Celsius or joule per kilogram per Kelvin. Alright, so here you must take notes that quantity of heat that is absorbed or released by an object can be determined by using the formula Q equal to mc squared. Okay, this formula, same with this formula. We just rearrange back only. Well, We are having many substances and they are having different specific heat capacity. Alright? So, different substance having different specific heat capacity. Okay? We having a few substance, liquid, gas, metal, and non-metal. They are having different specific heat capacity. Okay? Okay, now, after learning for the formula on how to calculate heat capacity and specific capacity, we come to application. Okay, application. So, selection building material of traditional houses in various climate zones. So, we have a look here, we have warm climate, we have cold climate. Okay, so wood, take note please, wood has a high specific heat capacity. So when any object which is having high specific capacity, it gets hot slowly. Okay, so therefore in warm weather, traditional houses are built from wood which function as insulator of heat, okay, from the scorching sun. In cold weather, traditional houses are also built from the wood. Heat from fires lit in the wooden houses cannot flow out because wood functions as a good heat insulator. Second application will be in our cooking utensil. So have a look here. We have a handle of the pot and also body of the pot. Okay. So body of the cooking utensil must be made up of aluminium. Okay. Why? Because aluminium having low specific capacity. Okay, this will enable the pot to heat up quickly. So any substance with low specific capacity will heat up quickly. However, the handle, okay, must be made up of high quality of plastic, whereby it is having a high specific capacity. So therefore, any substance with high specific capacity will heat up slowly or hot slow. So that's why it is safe for you to handle. So the next application will be cooked in the cooking utensil will be the metal wok and clay pot. So look at the woks, okay, made out of metal, also having low specific capacity. All right, so it will fry at a high temperature in a short time. Okay, well, on the other hand, clay pots, all right, it having high specific capacity, so food can stay hot for a long time. How about car radiator system? We have a few structure here. We got cover, radiator, airflow, fan, pump, and cooling fin. So burning of fuel, okay, will produce a large amount of heat. So this heat will be released, okay, to avoid overheating in the engine. So at the same time, we use the water as a car engine coolant, okay, cooling agent. So pump will pump water into the engine block. Water will flow through the engine block to absorb. Keyword here, absorb heat produced. Hot water flows to the radiator. Alright, cold air sucked in by fans. Okay, that's why it is cooling happen here. How about in the outer layer of space capsule? Okay, so in the journey back to the Earth encounters air resistance, or we name it as friction. Okay, this will cause high temperature and then maybe the capsule will burn. Okay, therefore, so outer layer of a space capsule must be made out of substance with high specific heat capacity, okay, and also high melting point. When we're talking about high melting point means not easily to melt. So we come to the next application, production of latest materials in the construction of green buildings. Okay, don't think that the green building is painted by green. No. Okay, we come and have a look here. So, roof fitted with insulator, or the material is styrofoam boards. Okay, why? Because this styrofoam having high specific capacity means it can reduce the absorption of heat from the surrounding. So the temperature inside the building is being cooling down. This is what we name as green building. Okay, green building. Well, sea breeze and land breeze. Okay, have a look here at the diagram. We're having land and sea. Okay, land has a low specific heat capacity than sea. All right. Therefore, temperature on the land rise more quickly in hot sunny day, okay, or daytime. Air on land become hot and rises upwards. Hot air is less dense. All right, you must take notes here. Cold air from the sea, all right, cold air from the sea moves towards the land. That's why we name this phenomena as sea breeze. On the other hand, land breeze. Look at the diagram. It is at night. Okay, sea has a high specific capacity than land, you should know. Okay, so temperature in the sea drops slowly, okay, at night. So hot air, which is less dense, above the sea, rise up. Hot air rise up. So cold air above the land move towards the sea. That's why we name it as land breeze. Okay, please keep in your mind sea breeze and land breeze. Okay, so come to the problem solving. Okay, we have a look at the questions. A slice of bread taken out from the refrigerator requires 15.2 kilojoule. We try to take out all the important data. So raise the temperature from 4 degrees Celsius to 42 degrees Celsius. Question asking, what is the heat capacity? Okay, maybe I leave you some while. Then you have to calculate, try to figure out the answer. Okay, let me show you the solution. Okay, well, okay, this is the formula. Okay, like I showed you just now. Okay, sorry for this. This is to the power of 3. Okay, it's to the power of 3. So you are going, after you substitute, this is the first mark, substitution. Okay, this is the second mark. Okay, so make sure correct with the unit. Okay, well done. I know you can do it. Okay, so now come to the experiment. Okay, experiment, very important. You have to do it, okay, in your school lab. So this is a setup. Retort stand, thermometer, water, beaker, tissue paper, immersion heater, and the power supply. Okay, first of all, what you need to do? Okay, you need to set up, okay, for sure. So you need to wrap a beaker with a tissue paper. I will discuss with you why later on. So you must place the beaker on top of the electronic balance. It's not showing here, but you try to get the mask and reset the reading of the balance to 0. All right. Fill the beaker with water until it is 3/4 full. Okay, you must record the reading of the mass M. Okay, M. Using the electronic balance. Okay, after that, you can see the thermometer here. You need to record the initial reading of thermometer as data 1. Okay, switch on. Switch on the immersion heater, and at the same time, you need to start the stopwatch. Okay, you need to observe the change in thermometer. Okay, around 5 minutes time, you need to switch off the immersion heater. You need to record the highest thermometer reading as data 2. Okay, so now we have a table for you, okay, to calculate the value of specific heat capacity of water. So power of immersion heater, heating time 5 minutes, mass of water you get from electronic balance, initial temperature of water theta 1 from thermometer, and after 5 minutes the final temperature of water theta 2. Okay, you can put in the formula to calculate specific heat capacity of water. A few important points that you need to take notes. Tissue paper act as insulator. Why? You need to wrap with tissue paper to reduce the amount of heat lost to the surrounding. Second, final temperature should not be taken as soon as 5 minutes heating time ends. This is to achieve thermal equilibrium before the temperature is taken. Next, okay, actually, whatever specific capacity of water that you obtain from the experiment is larger than the actual value. Okay, why? Because actually the heat really lost to the surrounding during the heating process. Maybe some of the heat supply is used to heat up the glass beaker. So, precaution or ways to increase the accuracy, maybe you need to wrap the beaker with a felt cloth, not with just a thin tissue paper, and you need to place the beaker on top of the polystyrene sheet to avoid the heat loss. So, felt cloth and polystyrene sheet. And you also can do the experiment to determine the specific capacity of aluminium. The procedure more or less the same, but one thing that you need to take note is, in the aluminium block, we having holes for you to put in the immersion heater and thermometer. So before you start the experiment, you should drop a few oil into the hole. Why? To ensure good thermal contact between the aluminium cylinder and the thermometer. Well, I hope you can conduct the experiment in your school lab and happy, enjoying. Thanks for watching. Thank you.